You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star.
Well, space just hit us with its hugest black hole collision ever. What? You didn't feel that? Well, actually, you weren't supposed to. 2 absolutely massive black holes spiraled into each other and smashed together, forming a brand new black hole about 225 times the mass of our Sun. This space catastrophe must have been epic, and if Earth had been in the way, it would have obliterated in a fraction of a second. Whew. Now, this whole event happened on the outer edges of our Milky Way galaxy, and we only caught it because of a team of super-sensitive space detectors called LIGO, Virgo, and Cagra. Now, these aren't new pop stars, and not even telescopes. They're more like giant cosmic microphones. They listen for gravitational waves, ripples in space-time that spread out when huge objects crash into each other. It feels like space is shuddering from the impact. Now, Einstein predicted such things way back in the day, and in 2015, scientists finally proved he was right. That win even scored them a Nobel Prize. So the two black holes that collided were around 100 to 140 times the mass of our Sun. That might not sound like a big deal until you realize one thing: they're not supposed to exist. There's this weird range called the mass gap, roughly between 60 and 130 solar masses, where theory says black holes can't really form. Because when massive stars go out, they usually explode into supernovas that blow away most of their mass before anything can collapse into a black hole. So black holes in this range shouldn't be here, and yet here they are. This is actually the second time we've seen black holes lurking in this mass gap. The first time we detected such an event in 2019, two truly huge black holes slammed together and formed one 142 times the mass of the Sun. That's a big boy. It happened 7 billion years ago. To put it in perspective, Earth is around 4.5 billion years old. Anyway, two black holes slammed into each other in deep space. One was about 85 times the mass of our Sun, the other 66 times. And when they crashed, they merged into a brand new cosmic monster, a 142 solar mass black hole. At the time, it was the biggest black hole collision ever caught. Now curiously, physicists weren't even sure black holes this massive could even exist. Scientists had this idea that stars that big would just explode and fizzle out, not become black holes. So this collision basically walked in, broke the rules, and left everyone rethinking the textbook. Now, fast forward several billion years. Hey, it's Brightside, we can do stuff like that. After traveling across space for longer than the Sun has ever been around, the ripple from that crash finally reached Earth. On May 21, 2019, it hit the LIGO detectors in the US and Virgo in Italy, shaking their laser setups for about a tenth of a second. One little cosmic bump, and suddenly scientists had proof those giant black holes were real. As for that missing 9 suns worth of mass, it turned into pure energy in the crash. That's what powered the gravitational wave strong enough to hit us after 7 billion years on the road. By analyzing the wave's shape, basically its wiggles, researchers could figure out exactly what kind of black holes were involved and how massive they were. We could compare it with hearing the faintest echo of a giant cosmic drum solo and being able to tell what kind of drumsticks were used. Now, in any case, every time something like this happens, it pushes scientists to rethink the rules of how black holes are born. The leading theory now is that such giants don't come from dying stars at all. They probably form when other, smaller black holes merge again and again, like cosmic Lego bricks, snapping together over time. Normally, black holes fall into two camps. There are stellar mass black holes, a few to a few dozen times the mass of the Sun. When a massive star, like 8 times heavier than the Sun, burns through its fuel, it doesn't just fade away. It collapses, rebounds, and explodes in a supernova. What's left behind depends on how massive it was. Medium big ones leave behind a neutron star, an ultra-dense remnant of a star. But if it were 20 times the Sun or more, it collapses all the way down into a stellar mass black hole. Now, most of the stellar mass black holes we've spotted are the clingy type, paired with stars. Some suck gas from their partner stars and light up in X-rays. We call those X-ray binaries. Thanks to those dramatic duos, we've found around 50 black holes in our galaxy so far. But scientists think there could be up to 100 million lurking quietly in the Milky Way. So yeah, we're surrounded. Next, there are supermassive black holes, the behemoths, chilling in the center of galaxies, millions to billions of solar masses big. Almost every big galaxy out there, including our own Milky Way, has a supermassive black hole. Our own galaxy's own heavyweight champ is Sagittarius A star. It tips the cosmic scales at about 4 million times our Sun's mass. That sounds huge, but compared to other galaxies, it's kind of a lightweight. Take the black hole in the galaxy Holmberg 15A, for example. It's got at least 40 billion suns worth of mass. Ooh, that's a big boy. How these mega monsters got so huge is still a mystery. Some faraway galaxies show us that supermassive black holes formed super early, like within the first billion years after the universe was born. One idea is that they started out as giant stars, collapsing in the early universe. Scientists know that these giants keep getting bigger by gobbling up smaller stuff, like stars, neutron stars, and even smaller black holes. And when galaxies crash into each other, their black holes can merge too, creating even bigger beasts. But the ones in the middle, the so-called intermediate mass black holes, are the unicorns. Rare, weird, and super hard to spot. That's why this new collision is such a big deal. It might finally be solid proof that these elusive in-betweeners are out there. So, how do we even know this record-breaking black hole crash happened? Well, it all started on November 23, 2023, when two ultra-tiny ripples in space-time passed through Earth. They were picked up by LIGO, the Laser Interferometer Gravitational Wave Observatory, which has two massive detectors, one in Louisiana and one in Washington. These places are like giant cosmic tuning forks, just listening for spacequakes. Each LIGO detector has two 2.5-mile-long arms in an L shape, with laser beams running down both sides. If a gravitational wave, like the one from a black hole crash, sweeps through Earth, it stretches space in one direction and squeezes it in another. That slightly messes with the timing of the laser beams. And even those microscopic changes are enough to signal that something huge just happened out there. Now, the signal they caught this time wasn't your everyday ripple. It was complicated because the two black holes involved were not only massive, but also spinning like crazy. And that's a big problem for astronomers. You see, when black holes spin super fast, the math behind tracking and understanding them becomes way messier and harder to pin down. So when scientists try to match this wild signal to their models, simulations of different black hole collisions, they didn't get one clear answer. Instead, they received a bunch of possible scenarios. What they do know is this: the black holes were huge, and one of them might fall into that mass gap zone again, that mysterious range where black holes aren't supposed to exist. But because the spin throws off experts' calculations, well, they can't say for sure. To get clearer answers, scientists need better models, and to build those, they need more examples of these rare, high-spin black hole mergers. Thankfully, that's not impossible. LIGO, Virgo, and Kegra have already detected around 300 black hole collisions since they started in 2015. And just in their latest run, 200 mergers. But here's the thing. This whole operation could be in danger. Unfortunately, LIGO is facing serious budget cuts, which might shut down one of its detectors. According to its director, without both detectors running, catching these once-in-a-universe signals could become near impossible. So yeah, we're getting better at hearing the universe whisper, but there's a chance we might have to start plugging our ears, just when it's getting interesting. Deep in space, something strange is stirring. Two black holes collide, sending ripples across the fabric of space-time. But there's a mystery hidden inside that gravitational hum. Is it evidence that black hole mergers may be far more tangled and thrilling than anyone ever imagined? Scientists may have just picked up something totally new, a third black hole hanging out in a black hole collision. Basically, when two black holes smash together, they make a kind of background hum. In one 2019 event, researchers noticed a weird signal inside that hum. It looked like a pair of black holes was speeding up in a way that didn't make sense, unless a third black hole was involved, hovering nearby and messing with things. It might be the first time anyone has found clear proof of a third compact object inside a black hole merger. When two black holes are stuck in a close orbit around each other, it's called binary black holes. Like regular black holes, these systems come in two main flavors, vanilla and chocolate. No, not really. One kind is stellar mass binary black holes. These form when really massive stars pass away in pairs. Ooh, how romantic. Or when two separate black holes end up capturing each other. The other kind is supermassive binary black holes. Scientists think they usually form when two galaxies crash together and merge. We got the first direct proof of stellar mass binary black holes in 2015 when LIGO detected gravitational waves from a massive collision, and it proved that not only do binary black holes exist, but that they also merge. Unfortunately, for supermassive black hole pairs, the evidence so far is indirect. Astronomers have spotted galaxies that look like they have two cores, which could potentially mean that each core has its own black hole. Others look like they might have two black holes hiding inside a single core. Some galactic centers even flash with periodic bursts of light. A giant object could be orbiting a black hole there. But there are also galaxies that show odd motion, which suggests a binary supermassive black hole. For instance, this galaxy has a black hole that seems to be moving in a strange way. It could mean it's part of a merger or a binary system. And then there's a quasar that looks like it has a pair of black holes orbiting each other every 1900 days. Binary black holes appear like this. When two galaxies smash together, their giant black holes in the middle don't usually crash right into each other. Instead, they just fly past on wide curves, unless something slows them down. That something is called dynamical friction. Basically, when a black hole passes near stars, it gives them a little slingshot boost, and in the process, loses some of its own speed. With more and more of these encounters, the black holes slow down enough to get stuck in orbit around each other, forming a binary. At first, this process works pretty well. But as the black holes get closer, they start to clear out the stars and gas in their path. With less material around to slow them further, they eventually stall. In the end, mutual gravitational attraction can make the black holes spiral together, but that only kicks in when they get very close to each other. And so, the big question is, how do they make that last jump? More stars or gas might drift close enough to the pair, and each time a star swings by and gets flung away, it steals a little energy from the orbiting black holes. Another possibility is the influence of dark matter, an invisible and hypothetical form of matter that does not come into contact with light or electromagnetic radiation. And there's one more dramatic option. What if a third supermassive black hole joins the mix? This could actually happen if the galaxy with the pair collides with yet another galaxy. Three black holes together create chaotic orbits, which open up two extra ways for energy loss. They wander through a bigger part of the galaxy, hitting and slowing down on more matter. Or their orbits get stretched into long ovals, and then, when they swing really close to each other, they lose extra energy through gravitational waves. So, has this third option just been confirmed? We'll talk about it a bit later. First, let's check out the life of a binary black hole in detail to understand this process better. The first stage is called the in-spiral. This is when two black holes are slowly circling each other while their orbit shrinks bit by bit. As the two black holes move closer together, they spin around faster and faster. This makes the gravitational waves much stronger. Eventually, they reach what's called the innermost stable circular orbit. It's basically the last safe orbit before they spiral in for good. After that, things speed up. The orbit eventually becomes unstable, and the two black holes plunge toward each other. When they collide and merge into one, gravitational waves hit their peak strength. This is the loudest, most dramatic part of the whole process. Right after the merger, the new black hole is kind of messy. It's stretched, distorted, and not stable yet. It goes through a phase called the ring down. During ring down, the black hole shakes off its uneven shape and settles into a smooth, stable form. While it's doing this, it gives off gravitational waves that mathematically sound like the fading echo of a struck bell. As the ringing fades, the waves get weaker and weaker. It means that the black hole is becoming calm, symmetric, and stable. Since 2015, when scientists first caught gravitational waves, they've logged about 300 black hole smash-ups, all thanks to the ripples, also known as gravitational waves, they've sent through space-time. By studying those ripples, astronomers can figure out how big the black holes are. Sometimes, the data even points to something called hierarchical mergers. That just means black holes merging, and then those new bigger ones merging again, and so on. It's like building up huge black holes step by step. Now, here's why that's important. Black holes born from stars can only be so big. When a giant star reaches the end of its life, it goes supernova. If it's under a particular mass, the outer layers blow off and the core collapses into a black hole. But if it's too massive, the whole thing just blows apart. No black hole left at all, just debris. So, if astronomers ever spot a black hole heavier than a certain limit, it means it probably didn't come straight from a star. Instead, it might have come from earlier mergers. Now, let's get back to the event we started our story with. It didn't break the mass limit. Actually, it was the opposite. One of the black holes was teeny by black hole standards, just 2.6 times the Sun's mass. That's so small, it's right on the edge of maybe not even being a black hole, but a neutron star instead. The other black hole was way bigger, around 23 solar masses. That size mismatch is super weird. Usually, binary black holes are way more equal in size. But here, one was a giant and the other was tiny. A team from the Chinese Academy of Sciences thought this odd pairing might mean something else was at play. They suggested the two black holes were part of a more complicated system, with a third, much larger black hole pulling on them while they orbited around it. To test this, they studied the gravitational wave data. If a pair of black holes is circling a third one, the signal should show a little extra acceleration along our line of sight. The team modeled how that would look and then compared it to the data they had about the event. And their model fit. The data pointed to an acceleration of about 0.0015 times the speed of light, with a 90% confidence level. That's a very strong hint that a third hidden black hole was really there. If that's true, it means black hole crashes aren't always simple two-and-done events. Sometimes they may happen in messier, more complicated setups. And there might be other strange cases hiding in the data, just waiting for someone with the right tools to spot them.
Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter. About 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment. Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide and seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new. A bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things. Really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear. The typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.
Imagine a black hole, a terrifyingly dense space object pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet. Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than that of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noted that two gigantic black holes were growing alongside of each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. Now, we can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we're talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other. And eventually, they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood. And this discovery may mean that such black hole binaries are likely to be much more common than we previously thought, too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists, consisting of more than 200 astronomers, had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they're really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we're not going to be pulled into this hole. It's more than 26,000 light-years away from Earth, and that's too far for this monster to have any influence on our planet. Besides Sagittarius A star, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Well, typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A star, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, You could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes, located in different galaxies, aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement.